Hello everybody and welcome to problem 1 on the final exam review problems. This is a problem that's in 3 parts and it's an exercise in doing u substitutions. A little bit different than a normal problem in the sense that they're not asking us to actually calculate these integrals. They would like us to just transform the integrals using the particular u substitution. Okay, so take part A here for example. Okay, they give us an integral and they also tell us what u substitution they'd like us to try, and our job is to see if we can rewrite this integral in terms of that new variable u. All right, so let's work through this together. So if we start with u equals e to the 2x, we're going to calculate our du that goes with that. So using u equals e to the 2x, du would be, we're going to take the derivative of that and just get 2e to the 2x dx. Next step is to solve for the dx, so we can divide through by the 2e to the 2x. Okay, we're going to take all of that information and see if we can rewrite the integral that we started with in terms of u. All right, so here's the integral that we were given. Okay, and you can kind of look at the integral and see that there are a couple of places where there's an e to the 2x, and we made the substitution u for that e to the 2x, so we'll replace those with u's. And then we're also going to fill in the dx that we calculated above. All right, so if we put all that together, we're going to get 1 over u times 1 plus 5u, and then the dx we can see from up here is equal to du over 2e to the 2x. Okay, and remember the goal is to get the integral rewritten entirely in terms of u. There's one piece that didn't cancel out here, this e to the 2x, but again, looking back up at the top, that's equal to u, so we can fill in a u for that. So this becomes du over 2u. Okay, and we're essentially done here, but we could simplify a little bit. So this over 2 is a constant that we could pull outside of our integral. And I'm going to do one more thing and take the u that's here and the u that's here and pull those together into one term. Just write this as 1 over u squared times 1 plus 5u. Okay, and at this point we're done. We've got an integral that's in terms of u's, and that's what they asked us for. Okay, let's move on to the next part here. Okay, so for b, same thing. They're starting us off with an integral with x's in it and giving us a u that they'd like us to substitute. So using that u, we're going to start by calculating du. So derivative of the square root of x is 1/2 x to the negative 1/2. Okay, which we could rewrite if we take that x to the negative 1/2 and move it into the denominator as 1 over 2 square root of x. Okay, and then we want to take that and solve it for the dx, so maybe we'll multiply both sides by 2 times the square root of x. Okay, and we'll see what we can do to transform our integral into an integral that involves u's. So if we start with the integral we were given, okay, we're going to look like that. And then notice that we've got a square root of x sitting there. That's going to become a u. And the dx, we can see from above, is 2 square root of x du. So the dx that you see here, we're going to fill in that 2 square root of x du for. Okay, well, you can kind of look at that integral and see we've still got a mixture of u's and x's, and we want to get an integral that just has u's in it. So we might notice that the square root of x that's sitting here, that's just equal to the u from the beginning. Okay, that's the choice that we made for u, so let's fill that in. 2u du. And the last thing is, what do we do about this last factor of x that's sitting here? Okay, well, that's not directly equal to anything that we have in our work above, but we can go fishing and figure out what that x is. The key is to maybe look back at the beginning here, u is equal to the square root of x, and notice, or ask yourself, how would we solve for x in that equation? Well, we could square both sides and see what x is equal to. X is going to be equal to u squared. So this remaining x down here, we can fill that in with a u squared. Okay, and again, we're essentially done. We could leave our answer like that if we wanted to, or we could take the 2u and the u squared and maybe combine them together, simplify a little bit. Those two circled pieces are going to turn into a 2u cubed times e to the 1 minus 3u. Okay, and there's our answer. And finally, let's go ahead and take a look at part C here. Same type of question. Okay, this time they're giving us a substitution of u equals x squared, so let's go ahead and calculate our du. Divide through by 2x to get our dx. And starting from the integral that we're given, okay, I'd like to give myself just a little more space on this one. Let's move that down a little. Okay, and again, our goal is to rewrite this whole integral in terms of the variable u. Okay, we made the choice to let u be x squared, so notice that the x squared that's sitting there, that's going to turn into a u. Okay, and then what about the x to the 6th? Well, if you look carefully at that, we could rewrite x to the 6th as x squared cubed as a way of kind of seeing that that's going to turn into a u cubed if we make our substitution. All right, so if we start by filling those two pieces in, we're going to get a sine of 5, and then x squared cubed is going to turn into u cubed. Okay, and then moving over, we've got cosine of 7u. Okay, we'll leave the x cubed in the bottom alone for now. And then dx, we can look up at our work and see that dx is equal to du over 2x. Okay, so there's where we're at so far. Okay, we can do a little simplifying in the denominator. So we've got an x cubed and an x. Let's put those together into an x squared. Okay, and we've still got, oh, whoops, that's a du, not a dx, sorry. And we still got a little bit of work to do because, again, our goal is to get an integral that just has u's in it, and we've got an x to the 4th in the bottom. Okay, but notice that x to the 4th can be rewritten as x squared squared, and since u is equal to x squared, that means that we're going to get a u squared in the bottom, okay, which kind of completes our substitution process. Okay, and that would be our answer. You could, of course, pull that 2 that's in the denominator outside of the integral if you wanted to, or you could leave it like this, and that could be our answer. Okay, and we're done.